We now know the reason of the outage that happened on November 25th for the US East-1 AWS Amazon Kinesis event. Amazon responded with a nice summary. It's a very long summary detailing what happened exactly, what was the cause, and there are lessons for us backend engineer that we can extract from this summary. How about we jump into it? So what I'm going to do in this article is that I'm going to do a TLDR for those who are just interested to know what happened exactly. So I drew a little bit of a nice nifty diagram because this is a very dry article to read. So I'm going to do a TLDR and then I'm going to dive into the deep analysis. So you're going to see the YouTube chapters where you can jump into the interesting part of the video. If you want to stay for the detailed analysis of the article, then I'm going to explain and go through and kind of ask some unanswered questions that I don't have yet, and stay on. So let's just jump into it. So guys, TLDR, let's go through the Amazon Kinesis architecture as described by this article. Amazon Kinesis have a bunch of back-end servers, and these are called back-end clusters. And each cluster is basically the core processing unit of those streams, right? Those click-throughs, these videos, these voice, any stream that you create in Kinesis lives on the back end, essentially. And to scale, naturally, we need to do sharding, and most companies do, right? So we have essentially many shards in a single backend for a single stream, data stream, right? So that's the idea here. So now all of a sudden we have many shards over many clusters. So we need some sort of a mapping, right? So like, okay, backend 1, which is, think of it as an IP address, has two shards, shard 1 and shard 2, and backend 2 has shard 3 and shard 4. So now the consuming part of this, which is their front end fleet. So that was the back end fleet. That's what the front end fleet. That was, by the way, what broke things down, the front end fleet, which accepts the traffic from outside, whether it's customers or just another AWS services. So these front-end servers communicate with the backend in order to write or read from a different shard based on what data stream you're reading. So they have this map. It says, okay, backend 1 has shard 1, backend 1 has shard 2, right? And same thing, this front-end machine has backend 2 has shard 3, and backend 2 has also shard 4. So those guys, in this case, I have only 2. Those communicate with each other. Very interesting, and very, very interesting choice of design, right? So all front end machines or servers actually communicate with each other in order to say, okay, are you healthy? Are you alive? And here, by the way, we're gonna exchange some of this sharding information. They call this the shard map. So the shard map is the most important piece that we need to understand here. And those machines exchange those shard map as they change, as the shard map changes. Like, let's say you as a customer added a new shard or removed a new shard. These front end need to be updated, right? So they communicate with each other and exchange this shard map information. So now they are in sync, essentially, right? So what happened when I add a new machine, right? Let's add a new front-end machine, just increase the capacity. All of a sudden now, this new machine needs to communicate with this needs to communicate with this, and this needs to communicate with this. So you effectively, it's very similar to a peer-to-peer architecture, right? So this communication, now each machine has 2, so essentially n-1, right? So if you have n front-end machines, you have n-1 connections, and each connection, it's the Apache model where each connection is a thread in the operating system. And this is very important, a very important point. So each connection is a thread. So now we have 2 threads here, 2 connections, 2 threads, 2 connections, 2 threads. So it's just so we can parallelize the information as they come, right? And as a result, we can sync all of them together. And that's not so bad if we have 3 machines. But Amazon they didn't specify the number, but they say thousands. My guess it's 10,000, right? Because that's the default thread size that after the operating system just dies. Right. So here's what happened, right? What happened is Amazon at 5 a.m. in the morning, they added a new capacity. This just regular thing they do. They keep doing this. They increase the front end servers. The backend is happy. They just want to increase the front end so they can accept more requests and essentially decrease their latency, right? So now, when they added that extra machine, right? They have thousands of machines. All of a sudden, they started getting all sorts of errors, failures everywhere. And long story short, so here's what happened. The addition of the new capacity, the new front-end servers, increased by a threshold that exceeded the number of maximum threads that any operating system can handle. That configuration for the operating system, whatever the operating system here, they didn't specify the number. My guess is it's 10,000. So if you go beyond 10,000, all of a sudden you cannot spin more threads. Guess what? If you don't spin more threads, you cannot create new connections, right, to that new machine that just joined. So God knows what will happen. Maybe it will create a new connection and will destroy another one from another machine. So all of a sudden, you have a corrupted shard map, right? Because what's going on here? It's like, what is the source of truth? We don't have a consistent view anymore. These connections are severed. So there are information that we need to propagate, but we can't. So we get errors and we get throttles as a result, and we get all sorts of errors. And that wasn't easy to determine. It took them a long time to get to that reason. So what they did is they actually said, okay, let's remove the new capacity that we added, and they restarted each machine in order for all of these to recommunicate slowly. And they stopped the outside traffic so that essentially they don't get overwhelmed, because these machines accept requests from the outside, from other AWS services and customers, and they also accept requests from their neighbors, right? Whatever that means, right? My guess is that everyone is connected to everyone, and we have a specific paragraph saying that in the summary. It's like every machine is connected to the other machine. So now I have many questions, and we're gonna dive deep into the details on like what exactly happened. And before we jump into it, let's go back. So that was the summary. So let's go and start reading this article and then kind of break it apart. Amazon Kinesis enables real-time processing of streaming data in addition to its direct use by customers. Kinesis is used by other AWS services, okay, as we described. The services also saw impact during the event, right? Any outside words, which is AWS and customers, to me, that's a big mistake. You're sharing resources between your internal services and external customers. These should be separated. And that's one of the solutions they did. In the end of the article, they say, okay, that was a mistake. We should not do that. Let's separate those two. I mean, if you have confidence on the architecture, which they did initially, but it did not scale well. The trigger, though not the root cause for the event, was a relatively small addition of capacity that began to be added to the service at 2:44 a.m. Oh, so I was wrong. So it was in the morning. They added in the morning, and they finished at 3:45 a.m. So it took an hour to add this. So here's the details now. Kinesis has a large number of backend cell clusters that process streams. Those are the backend architecture that we explained in the diagram. These are the workhorses in Kinesis, provide distribution, access, and scalability for stream processing. Streams are spread across the backend through a sharding mechanism owned by a front-end fleet of servers. Those are the front end that we explained. A backend cluster owns many shards and provide consistent scaling, unit, and fault isolation. Yeah, of course you need. They are replicated. They're everywhere. They're just not unique, right? You have to duplicate it in case of a fault. Let's say, what if a backend server or cluster fail, right? You need to kind of do a load balancing on that. The front-end job is small but important. It handles authentication. That's something I didn't explain. So it authenticates. It throttles, which they actually implemented during the outage. They throttle everyone, and request routing to the correct stream shard. That's the most important one. The capacity addition was being made to the front end fleet. Each server in the front end fleet maintains a cache of information, including membership details, shard ownership for the backend cluster, called a shard map. That's the word we talked about. This information is obtained through calls to a microservice vending the membership information. So the membership information, I don't know what's exactly the membership here. Are we talking about the actual Amazon memberships? Like, hey, are you authenticated or not? I guess the authentication part of it. Retrieval of configuration information from DynamoDB and continuous processing messages from other Kinesis front-end servers. That's the peer-to-peer communication that we showed. For latter communication, each front-end server creates operating system threads, and there is a threads with an S, for each of the other. That's what made me realize that it's a peer-to-peer, almost like everyone is communicating to everyone. That's just very bizarre architecture, in my opinion. I still don't know what kind of information being exchanged between all these machines, and can you just have a centralized system to store the cache? That's the first thing that I was like, whoa, why are you guys communicating between each other? It's just very inefficient. We tell people, hey, peer-to-peer is great for a few people, for a few machines, for a few participants, but the moment you exchange and explode to multi hundreds, it just doesn't scale, right? We know this, the mesh architecture, right? But any addition of capacity, the servers that are already operating members of the fleet will learn of new servers joining and establish the appropriate threads. It takes up to an hour for an existing fleet member to learn of a new participant. That's the time it took them, right? They added the machines at 2:44 a.m. They finished 3:44. Exactly an hour, right? So it tells you that is extremely inefficient. Why would an adding of a single machine takes an hour to update? Can we make it better? Again, guys, we don't know a lot about the background of the architecture before we judge, right? There must be a reason for everything. I'd like to always, before asserting anything, I like to know the reasons. And to us, we don't know. So there must be a good reason for everything those companies do, right? We just don't know it yet. In this paragraph, they explain that exactly when they started to see the error at 5 a.m. So it took around 1 hour, 1 hour and a half to start seeing the first alarms. Again, the teams started reading the logs and see what happened, or what did we do? We added a capacity. What's wrong? We add capacity all the time. Why now? So they immediately started removing the capacity. Even removing the capacity is slow. The diagnosis work was slowed by variety of errors observed. Because it's all the wild west now, right? Because if I can't communicate with the other server, and you get cascading errors, and you get some weird errors that, I don't know, I can't access a server. Maybe you just try to access a server that a backend that has been removed, but you just didn't get the updated shard map to know that it has been removed, or a new shard that has been removed, and you're connecting to a shard that doesn't exist. So you start getting these errors, but you have to put 2 and 2 together, and that's absolutely difficult. So I can totally relate to that, because in my career, I've seen so many errors. I mean, just the other day, I've seen an error that took us a lot of, I don't know what, it took us like 3 hours to find out the root cause of, and has the error has nothing to do with the root. When you first read it, it's like, why? And I'm sure a lot of you guys, if a lot of you guys can relate to that, can you, in the comment section, just write what is the most interesting diagnostic and troubleshooting experience? If you can share that as well, of course. So here's, they say, like, we just want to go back. We just want to go back. So they're starting to go back and remove the extra capacity they added, so they can just restart the system and go back. But again, if you do that, remember, every machine you introduce takes an hour. according to them, right? So if you removed everything, you have to remove everything, because guess what? All the front ends now have corrupted shard maps. There's no solution. You have to destroy all the, restart every single front end, and every front end you introduce and you add another one takes an hour. So that's why it took a long time to actually retrieve that. So they need to work on a better their cold start problem, apparently, because they have a slow cold start here. There you go. There is where they actually find out. At 9:39, we were able to confirm the root cause. And it turns out this wasn't driven by memory pressure, rather than a new capacity had caused all the servers in their fleet to exceed the maximum number of threads allowed by an operating system configuration. They didn't say what that number is or was. As the limit was being exceeded, cache construction was failing to complete, and front-end servers were ending up with the useless shard maps and left them unable to route requests to backend cluster. That's exactly what we talked about, right? Or they try to connect it with backend cluster that just doesn't exist anymore, right? Or don't exist. We didn't want to increase the operating system limit without further testing. Because that's the first, since we know, let's just increase it. It's not tested. You have not tested that. So, and that's just, if you're adept in software engineering, you don't try something you never tried before in production. That's just a recipe for disaster. And we had just completed the removal of additional capacity that triggered event. We determined that the thread count would no longer exceed the operating system, because they know that it worked before. So let's just stay as, let's just remove the capacity that we added. So we go back to the existing number of threads, which didn't exceed, right? We began bringing back the front-end servers, with the first group of servers taking Kinesis traffic at 10 a.m. The front end, so they started rolling back, starting everything at 10 a.m. in the morning. That's the morning of 25th, I guess. The front end fleet is composed of many thousands of servers. Many thousands. They didn't say how much. And for the reasons described earlier, we could only add servers at a rate of a few hundred per hour. So they can add a few hundred per hour. Oh, all right. It's not just one server per hour. Yeah, okay. That kind of make better sense. We continued to slowly add traffic to the front-end fleet, with the Kinesis error rate steadily dropping from the noon onward. Kinesis fully returned to normal at 10:23 p.m. Pacific Standard Time. That was a long outage. I'm glad they actually wrote this. This is good. This is really good. It does leave me thirsty for more answers, though, and I have more questions. For Kinesis, we have a number of learning that we will be implemented immediately. So they learned from this outage, like any software engineer should. You have a disaster and you learn from it. It's like, how can I prevent this? And those big companies, that's the first thing they tell each other. Say, hey, all right, no big deal. You guys did this. What could you do to prevent this? That's the CTO will immediately say that. What can we do to prevent this in the future? In the very short term, we'll be moving to a larger CPU memory, reducing the total number of servers. That's a hack, in my opinion. Let me explain what happened and why I think it's a hack. Because they have smaller servers with smaller CPUs, so they need more front ends in order to kind of accept that X amount of load or requests, right? So they said, okay, and we can't really have a lot of front end because our architecture doesn't scale as a peer-to-peer system, right? Because these machines are communicating with each other. So let's minimize the number of servers that we need. Yeah, that might work, but you still have a lot of servers that communicate with each other, and we still don't know what are they communicating, right? Are they communicating just the cache map? They're gonna say, hey, we move the cache into a centralized cluster and all the front end will just read from the cache. That makes sense, right? Yeah, it's a centralized server, but still the centralized server cluster is still on many machines, but they're not gonna be at more than 10 machines. And that's enough, right? And those can share the cache and they propagate the cache nicely, but and all the fleet can just read from this centralized cache. But regardless, they say, okay, we'll just minimize the number of servers, make them vertically scalable instead of horizontally. Hence, the threads required by the server across the fleet will be minimum, essentially. Yeah, I don't know about this one. I think they have to revise their architecture, in my opinion. This will provide significant headroom in the thread count used as a total thread each server must maintain is directly proportional to the number of servers in the fleet. Well, we know that. Having fewer servers means that each server maintains fewer thread because it's the thread is one-to-one to the front-end server, almost, right? So we know that if you have n front-end, it's n-1 according to our graphic, but that calculation might not be accurate. I've just made it up because they say threads. So it could be actually more than one thread for each server. So it could be double. Who knows? And as a result, it could be just expanding. And we still don't know why these front ends are talking to each other. Are they heartbeats? Can we just do neighbors? Maybe they're just, they talk to each other. I'm just making some assertions here. I'm not necessarily correct. My guess is that these are heartbeats to detect if a front-end machine has went down in order to remove it from the fleet. That's just a guess. But even though, can we have a better approach without communicating with each other? Because you need to communicate with each other. I mean, Cassandra does that, right? Cassandra and their shard, right? In their sharding system, they have a shard ring, and if you add a new system, it just talks to the neighbor because it's a shard ring. It's not a shard peer mesh. It's not a shard mesh. It's a shard ring. So if you add a new shard, it just says, "Hey, I'm a new shard. Can I have I don't know, half a gig from you and half a gig from you, and I'm gonna saturate you a little bit. Let me get my traffics from you." So yeah, there are some communication, but it's just very minimum, right? And instead of taking from the all fleet, that's something Cassandra. Again, I'm by me wrong, but I believe Cassandra fixes that limitation in Dynamo. Dynamo was taking from everyone, right? So when a shard entered the ring, it was taking from everyone, so it's saturating the network of whether if a shard leaves or enters. Okay, while Cassandra, they just took from the sides. There is a slight. Again, I'm making all of this stuff up, guys. Don't take my word for granted. But it's just analysis. That's what we do. We analyze backend. If you don't have answers, we analyze. Why? We could be wrong. Of course, we could be wrong. Who cares? I'm not saying that this is the truth. I'm just saying I'm an analysis, and you guys are gonna have hundreds of comments that you guys analyze, and I love those analysis. That's what we do. We analyze. We are backend engineers. We make assertions. Let's continue. So that's my guess. Right. So yeah, peer-to-peer and this mesh architecture, I don't think it's working. In my opinion, is just, unless they are doing something that cannot justify that communication, but I don't know. We are moving front-end cache to a dedicated fleet. There you go. That's what, when I first read the article, I was like, why don't you move the cache in a dedicated cluster? As a result, they just did, right? So the cache is now a dedicated fleet. So maybe it's a smaller fleet. So, but they're still insisting on the communication between all the front-end servers. And I don't know why. I'm so curious to know. If you move the cache, then those front-end stinking servers don't need to talk to each other, right? You just moved it to a fleet, right? So you communicate to that fleet and that's it. We will also move a few large AWS servers like AWS to a separate partitioned front-end fleet. Okay, so they're also moving these guys, so it is not depending on a Kinesis as much. In the medium term, we will greatly accelerate serialization of front-end fleet to match what we've done with the backend. All right, so they're gonna shard the front end too. Serialize. I'm not familiar with that word, guys. If you know what, I don't know what that is. Serialization is an approach we use to isolate the effect of failure within a service, okay? And to keep the components of the service, in case of the shard map cache, operating within a previously tested and operating range. Okay, are they sharding the cache? This had been underway for the front end fleet in Kinesis, but unfortunately the work had not been completed. Now they explain like why other services went down as well. So there are a number of services that uses Kinesis that impacted. Amazon Cognito, a lot of you guys in the previous video that I made mentioned that Cognito went down, right? So Amazon Cognito uses Kinesis data stream to collect analyze API access pattern. So Amazon Cognito uses Kinesis data stream to collect and analyze API access pattern. Can you guys opt out of this as a customer? For people who uses Kinesis, let me know in the comment section. Can you guys opt out of this analysis of the API pattern? Because I don't know. Do you even know that they are doing this, the analysis of the API access pattern? I don't think you can opt out. They just want to optimize, so they analyze these patterns, API access. While this information is extremely useful for operating the Cognito service, this information streaming is designed to be best effort. Data is buffered locally, allowing the service to cope with latency or short period of unavailability of the Kinesis data system. So there is some buffering going on, right? Unfortunately, the prolonged issue with Kinesis data stream triggered a latent bug in the buffering code that caused Cognito's, oh my God, that is genius. Okay. A latent bug in the buffering code that caused the Cognito web server to begin to block on the backlogged Kinesis data stream buffer. So I guess the buffer, you cannot just, because the Kinesis was down, you still, Cognito started buffering, and I guess it ran out of buffer or triggered a bug with the buffering code. As a result, Cognito experienced elevated API failure and increased latencies for Cognito user pool and identity, which prevented external user from authenticated or obtaining temporary AWS credential. My God. Look at analyzing an API, which is something you don't want to do, right? It's just collects and analyze API. This is as a side effect. It's not something that has to do with Cognito, yet it brought down the Cognito web servers. There is a big lesson for us to learn here, guys. You ain't gonna need it. If you're not gonna need it, don't add it to the feature, right? Because, yeah, look at this. This is, oh my God. So in the early stages of the event, the Cognito team worked to mitigate the impact of the Kinesis error by adding additional capacity and therefore increasing their capacity to buffer calls to Kinesis. Okay, so they just increase the buffer capacity so that they buffer more instead of failing. All right. I'm glad that Amazon is doing that, by the way. It takes guts to write this, right? Telling you like, guys, by the way, we're doing this. We're collecting this API stuff. I know that has nothing to do with Cognito, but yeah, it actually brought your server down. Although the Cognito team literally didn't do anything, right? Their server is up and running. They have just a bad code so that when I try to buffer these analysis API for Kinesis, they can't send it anymore, right? So it started buffering, collecting all these APIs to be analyzed, but they, I guess, crashed the server. Okay, can't take more. These should be like stored somewhere, but they fixed that. I'm glad they actually fixed that very quickly. All right. While this reduced the impacts by 7 a.m., PST error rates increased significantly. The team was working in parallel on a change to Cognito to reduce the dependency on Kinesis. There you go. That's what they should do. There should not be a dependency between Cognito and Kinesis, because Cognito's, what is Cognito? Let's search about that. Oh, so it's an identity system, essentially. You can log in with Facebook, Amazon, Google using Cognito, essentially. Okay. Let me know, guys, if I get that right. But yeah, that's what it is. To reduce dependency on Kinesis. So they started working on that. And 10 a.m. deployment of this change began and error rate began falling. Okay, that's wow, guys. Those are badass. They implemented reducing the dependency in few hours. Some engineers, man. There's some badass engineers. Guys, I want to give a shout out for all the Amazon AWS engineers that worked on this and managed to fix this, you guys are the real hero, in my opinion. Because that must have been very stressful, right? I should have started with this. Guys, kudos and great job. Like from all the teams, look at this. The Cognito team has nothing to do with Kinesis, but it went down. And they immediately started implementing a fix to reduce the dependence on Kinesis. That tells me there's a fluidity when it comes to Amazon, and there's like every team is like reactive, which is great. I like this. It's not like a centralized entity that makes the order. They just, otherwise it's gonna slow down. All right, let's continue. In 10 a.m. In the morning, deployed of this chain began, and error began failing. By 12 p.m., error rates were significantly reduced, and 2 p.m. Cognito was operating normally. To prevent a recurrence of this issue, we have modified the Cognito web servers so that they can sustain Kinesis errors without exhausting their buffers. Okay, so they fixed that bug so that it's like, okay, even if Kinesis failed, we still can continue normally, which is awesome. This is what, yeah, because that extra server that we're doing has nothing to do with the main job of Cognito, right? They should be independent. Less coupling. CloudWatch uses Kinesis data stream for processing metrics and logs data. Starting at 5 a.m. PST, CloudWatch experienced increasing error rate and latencies for the put metric data and put log API. And that makes it like CloudWatch has to go down because it is dependent on Kinesis. Unlike Cognito, which is like a side thing. Hey, we're going to analyze the logs. Let's just, any API call that we make, we're going to analyze it. Let's put it in Kinesis so we can stream it and analyze it later, right? So as we do that, that should not affect it. But CloudWatch, yeah, it is its main dependency. So of course it's going to go down. CloudWatch experienced increased errors, and we said alarms transition to insufficient data state. Ugh, why? While some CloudWatch metric continued to be processed throughout the event, the increased error rate on latencies prevented the vast majority of metric. While some CloudWatch metric continued to be processed throughout the event, increased error rate and latencies prevented the vast majority of metrics from being successfully processed. At 7:47 p.m., CloudWatch began to see early signs of recovery as Kinesis data stream availability improved, right? Because I think their front end started, I think they give the priorities to CloudWatch so they can spin up all these services and get it up and running. And by 10:30 p.m., CloudWatch metric and alarm fully recover. Delayed metrics and log subsequent. All right, so we know that. Okay, this is dependent. This service is dependent. That's good. The Cognito one was really interesting, in my opinion. 2 services were impacted as a result of the issues with cloud metrics. My God, look at this. It's a chain. It's a cascading chain. So Cloudflare metrics. First, reactive auto-scaling policies that rely on CloudWatch metrics experience delays until CloudWatch metrics begin to recover. So this thing that's called auto-scaling policies dependent on CloudWatch, which depend on Kinesis, which depends on their internal architecture, the front end. And once something fails, all of the other cascading thing just cascades and fail. Oh, this one is interesting. Let's see. And second, Lambda saw impact. Lambda functions, or the serverless functions. Lambda function invocations currently require publishing metric data to CloudWatch as part of the invocation. Lambda metrics agents are designed to buffer metrics data locally for a period of time if CloudWatch is unavailable. All right, that same thing we saw with Cognito. It's buffering stuff. Starting as it's buffering stuff locally so that it can send it at a later time. Starting 6:15 a.m., this buffering metric data grew to the point that it caused memory contention on the service's other host of Lambda invocation. That makes perfect sense. Like if you have like a Lambda services, right? You execute a serverless function. That serverless Lambda talks to CloudWatch, which talks to Kinesis, which is down, right? So that service decided to buffer things in memory. And as request comes in, so the buffer causes the memory to grow. And as the memory grows, your Node.js serverless function cannot no longer execute, resulting in errors. It feels so good when you actually understand what's going on, man. That's really good. It's like, just understand, like, oh, this is because of this. This is because of this. Everything has a cause and effect. At 10:36 a.m., engineers took the action to mitigate the memory congestion, which resolved the increased error. So Lambda was fixed very early, right? The Lambda engineers, they just said, hey, wait a second, why are we buffering this thing? Let's just maybe flush it to disk or something like that. They didn't say that, but I'm just assuming they flushed it to disk. Otherwise, why would you keep it in the memory? This is useless information, right? I rather execute the user's data function rather than keep it in memory. Some metrics. CloudWatch events and EventBridge experienced increased API errors and delays in event processing starting at 5:15 a.m. As Kinesis availability improved, EventBridge began to deliver new events and slowly process the backlog of older events. Elastic Container Service, and Elastic Kubernetes Service both make use of EventBridge to drive internal workflows used to manage customers' clusters. This impact provisioning of new cluster, delayed scaling of existing cluster, and man, this one is serious, guys. I didn't realize how serious this thing is. So Amazon Kinesis is the heart of the entire AWS system, looks like it. Man, that wasn't a fun day for AWS. I wonder if the AWS Amazon stocks will go down after this. Because that kind of... Because now, as they start revealing that architecture, people will have second thoughts like, holy, this thing is, first, it's proprietary. Second, they have a centralized system. Everything is relying on this Kinesis thing. And if this Kinesis went down again in the future, I don't know. People might lose trust in Amazon. What do you guys think? Let me know. It's just nuts that everything rely on Kinesis. I did not know that. Outside of the service issue, we experienced some delays in communicating service status. Yeah, I saw that. Like, even we cannot even tell you that the service is down because our service. I'm gonna kill myself if the service status page depends on Kinesis. Let's read this out. By the way, I didn't read this bottom. I only read the interesting part, the beginning. So I'm reading this for the first time with you. We have two ways of communication during the operation event. The service health dashboard, which is our public dashboard to alert customers of board operational issues, and personal health dashboard, which we use to communicate directly with impacted customers. With an event such as this one, we typically post to the service health dashboard. During the early part of this event, we were unable to update the service because the tool we use to post these updates itself uses Cognito, which was impacted by the event. I didn't mean to laugh. It's just funny. The dependency tree. It's like, this tells me that Amazon better gets their ducks in a row and make Kinesis really scalable. It's not scalable today. They have to solve the cold start problem. They have to stop this peer-to-peer mesh architecture that they have. The front-end services should not talk to each other if they don't have to. Again, we don't know the story behind it. Maybe there is a good reason that for them to have to talk, because I didn't see an architecture where machines talk to each other in this verbose manner. It's just, I don't know. I don't think that's a good idea because it's not scalable. But yet Amazon is the biggest cloud provider. So what do I know? So yeah, so the Cognito is this identity provider, and it looks like it's a web server. So it depends on the service health dashboard, which uses Cognito, which uses which fires up this analytics API metrics to Kinesis, which was down, and because of the buffering bug in Cognito, that was impacted for a few. So they fixed Cognito, which fixed any upstream services or downstream. Man, this is overloaded. I guess it's downstream, which was impacted by this event. We have backup means we have backup. Okay, English. We have a backup means of updating the service health that has minimum service dependencies. Yes. While this worked as expected, we encountered several delays during the earlier part of the event in posting to the service health, as it is more manual and less familiar for support operators. Okay, so because it's a manual process, they weren't updating as much, so they were relying on the automated. I mean, as they should rely on automation. I mean, who knew this will happen? This is a great lesson for all engineers. Thank you, Amazon, for being so generous and writing this summary. We love you for this. To ensure customers were getting timely update, the support team used the personal health dashboard to notify impacted customers if they were impacted by the service issues. We also posted a global banner summary on the service dashboard to ensure customers during the remainder of the event. We continue using a combination of the service health dashboard with the global banner summaries and service details, while also continuing to update impacted customers via personal health dashboard. Going forward, we have changed our support training to ensure that our support engineers are regularly trained on the backup tools for posting service health. Okay, so they're saying that, hey, the service health, don't rely on the automated, do the manual thing where you just literally type it in, then just or use like, I don't know, their service. All right, that makes sense. These measures are great. Finally, we want to apologize for the impact this event caused for our customers. While we are proud for long track record of ability Kinesis, yeah, you guys nailed it. I mean, I did not hear of an outage like this before in Amazon, because I keep up to date with outages, and Amazon is barely goes into outage. If it does, it's a few minutes and goes back up. So this one, when it happened, it happened hard. So it is scary. We now know how critical the service and other AWS services that were impacted are to our customers, their application, end users, and their businesses. We will do everything we can to learn from this event and use to improve our availability even further. Guys, we saw two patterns here. The first pattern is the Amazon Kinesis architecture, which is, I still do not fully understand why it is a mesh in the front end, at least, where all these servers are talking to each other, right? They fix that. They claim they want to move the cache map of the shard to a different fleet, to a different cluster, and have all these front end just talk to the fleet to obtain the cache, because that's what we usually do, right? But they still are keeping the one-to-one peer-to-peer communication between these front end, and I do not know the answer to this, and this article does not explain that. I am speculating it's a health. It's like, hey, by the way, I'm alive, but do you really need to communicate to all servers just that you're alive? Doesn't make sense. Just the neighboring is enough. Again, the second thing is just the dependency on Kinesis. I mean, if Kinesis is so powerful, then yeah, sure, you can depend on this cascade, and it's very, very simple for us to use a service. But once this service starts depending on another service, like we saw with CloudWatch, right? CloudWatch depending on Kinesis and some Elastic, I don't know what, depends on CloudWatch, which depends on Kinesis, and their health service their health status depends on Cognito, which kind of not really depends on Kinesis, but has this this metrics logging system that does in the background, which creates a buffer, which creates a memory contention, Lambda, all of this stuff. They have fixes for it, but it's just, I'm a little bit still worried about the architecture in the front end. It's like the cold start of those front end, and just adding and removing service is so slow. I think they need to do something about it. That's the article, guys. That's my analysis. That's my 2 cents. What do you guys think? Let me know in the comment section below. Were you affected by this outage? And what do you think about this architecture? Let me know in the comment section below. I'm going to see you on the next one. You guys stay awesome. Goodbye.